All right, what's going on, everybody? My name's Tom Grogan. Tonight I'm going to be talking to you a little bit about the programming language Kotlin. So let's start right at its roots. Kotlin was created in July of 2011 by the Czech company JetBrains. JetBrains was formerly known as IntelliJ. A lot of you might recognize IntelliJ from that very popular Java IDE that I know I myself used in CSC 145 and 146. Now, Java, the programming language, was named after an island in Indonesia. JetBrains kind of wanted to follow that naming pattern with Kotlin, and so they named Kotlin after an island just off the coast of St. Petersburg, Russia. Their goal behind Kotlin was to create a new language for the Java virtual machine that had plenty of features while retaining extremely fast compilation times. JetBrains really does see this language as a natural next step forward from Java and hopes that businesses will adopt it as their new standard. Let's go ahead and point out the differences between Java and Kotlin. So, I'm sure you all remember dealing with null pointer exceptions in Java. Kotlin differs from that in the fact that it will fail at compilation if it recognizes that a null pointer exception would be thrown. Java, when you are trying to create an object, you need to define member variables, constructors, accessors, mutators. I'm sure you all understand what I'm talking about. We did it hundreds of times in that first year of computer science. Now with Kotlin, it has this unique aspect called data classes, where it kind of does all the work for you. We'll look at some code in a little bit that will probably help you visualize what I'm trying to talk about here. But anyways, moving on. Java requires explicitly defined variable types. So if you're trying to create a new variable, the first thing that you need to write is what type of variable it is. For example, if you're trying to, just as an example, int example equals 100. Obviously, Java is going to recognize that as an integer. With Kotlin, you can just write variable example. And based off of how you are trying to work with that variable, Kotlin will recognize the data type that you were trying to go for in its definition. So another great benefit of Kotlin is resizable data structures. That was such a pain in the butt with Java because arrays are non-resizable. It's very difficult to mutate the data elements in an array. Kotlin has this unique data structure called a mutable list, which has built-in methods that support resizing, adding and removing, creating sublists. It goes on and on. There's literally hundreds of methods that you can use that are just built into the Kotlin language that let you work with data structures in a much more efficient way. Now, Java, I'm sure we remember when we were just getting into object-oriented programming back in 145, when classes would extend one another, and we would need to use that super keyword to call the constructors from the parent class and the methods from the parent class, and so on. Kotlin has this unique feature called extension functions, where you can kind of define a function that can be used with any variable within your project. So I know that was a lot of info to throw right at you. Let's look at some code and actually, break down what I'm trying to teach to y'all. So when you're creating an object in Java, I'm sure you all remember, you define your class, you'd add its member variables, you get its default constructor, sometimes a parameterized constructor, then you define its accessors, its mutators, and then maybe a member variable. Now in Kotlin, it takes all that weight off your shoulders and does all that work for you. So when using Kotlin, if you're trying to create a new object, you use that data class that we were talking about in the last slide. So in the same vein, you just type data class apple, you have a variable for weight of type double, and you have a variable price of type double. And it will automatically be able to generate accessors and mutators in the same way that you would call it in Java. And it also supports a native toString method and Boolean comparison methods and several other standard methods that you would usually see when creating an object in Java. Moving on to defining variables. When we talked about Kotlin being able to infer what kind of type of variable you're trying to work with, you can just type in, you have this new value. I just used example here. I set it equal to 100. And then say you wanted to print the line example plus 1, it'll print out 101. Now, Kotlin there recognizes what kind of variable you're trying to work with. If you did that in Java, if it was defined as a string, this print line would come out as 1001. And if you did it as an integer, it would come out as 101. Java recognizes that, hey, you're probably trying to work with numbers here, so it's going to respond with 101. Now, you don't always have to have Kotlin inference what data type you're trying to work with. You can also define it. I showed it down here. So instead of, just setting it equal to 100, you can do value example, and then you can set the data type that you're trying to work with, set it equal to 100, and it would do the same thing. Versus in Java, the very beginning of when you're trying to initialize a variable, you need to tell Java what data type you're trying to work with here. So I just used string example, and then in quotes, defining a variable in Java, and then it'll print that out. Kotlin is very unique in the fact that it can kind of figure out what you're trying to get at just based off of what variable comes, what you type in after that equals sign when you're trying to create a new variable. Now, this is one of my favorite parts about Kotlin. It retains all the things we know and love about Java and adds an absolutely immensely helpful feature with a data structure that is resizable, these mutable lists. So it's also possible in Java. We all remember, working with linked lists and trees, and there's so many of them. I included a screenshot of the code that goes behind setting up a linked list. There's a lot there. Kotlin has a built-in data structure called a mutable list. And this mutable list supports many functions that are already included in Kotlin libraries. I'll just go through the list here. You can add an element to the list. You can clear the list entirely. You can remove an element from the list. You can set the index of the list to something else. A really interesting feature is sublist, where you can take the initial list, and create a new list based off of the indices that you define in this sublist method. There are hundreds of methods that can be used to work with these mutable lists. In case you were wondering what that E means, it's similar to how when we defined a general linked list in Java, we use that T for type. E is basically just means that it's a generic mutable list. That E can be replaced with any variable type that you would want it to be. Just in this example, I used E to compare it to setting up a general linked list in Java. Let's talk about extension functions. So in Java, when you're trying to use functions between two different classes, you are very likely to need object inheritance. So one class needs to extend its parent. So that was used with that super keyword. I added a little snippet from one of our projects in 145 when we had the class student extending person. The method that we're comparing here is the equals method to see if two person or student or person objects are directly equal to one another, and it will return true and false. Kotlin makes it a lot easier with this feature called extension functions. So you can define a method that can be utilized with any class. It takes away the need for object inheritance, increases overall speed and functionality. So it's defined here. It's going to return a Boolean. The method is called .sameAs. It'll take in its parameters and make the comparison. And as long as you set up the parameters right, the extension function will be able to return true or false if the variables are the same, no matter what type of object you call that function from. So let's look at some other advantages of Kotlin here. The compiler is incredible. Kotlin can be compiled to JavaScript or directly to bytecode using the Java virtual machine. By compiling through a virtual machine, Kotlin source code can be run on any platform that has access to the Java virtual machine, which, when it boils down to it, is pretty much every relevant platform that you're seeing today. It's really unique in the fact that when it's compiled, it's not running directly on your CPU, but it's running in that virtual machine. And so that means your Kotlin code can be shared and able to be run on any platform based off of, if you wanted to email it to someone or if they wanted to download it off the internet. Another crucial advantage of Kotlin is that it's backwards compatible. Kotlin is completely built around Java, which means it has access to all of Java's libraries and frameworks. Kotlin can be translated to Java based off of an integrated app that the IntelliJ IDE includes, where Kotlin can be translated directly to Java and Java can be translated directly to Kotlin. Makes it very easy to understand the parallels between the two languages to someone who may understand one of the languages and not understand the other. Another huge benefit of Kotlin is that the syntax is extremely readable. You're not dealing with having to put a semicolon after every line. It's really just looking at it line after line. It's meant to be completely straightforward and really from a readable standpoint, extremely logic based. So ideally, that makes it understandable to someone who hasn't had that much experience programming in Kotlin. So the big question here is, will Kotlin really replace Java? Let's take a look. So I added I listed out a couple of reasons why a business would switch to Kotlin. So because it's completely interchangeable with Java, businesses already using Java would not need to take a large risk when trying to make that transition to using Kotlin. It's a lot more feature-packed. However, it doesn't sacrifice the more veteran developers in the business not being able to understand how to read Kotlin, because it's, the IntelliJ has added that function of being able to translate it. It makes code reviewing extremely easy. Going right into code reviewing. Kotlin is incredibly readable. Even if someone doesn't have a lot of experience programming in Kotlin, going line by line and analyzing it logically, it's not difficult to understand what the programmer is trying to accomplish with their code. Now, say someone is a little stubborn and they have been programming in Java for decades. They don't want to start reading this new programming language. IntelliJ has included the feature that you can just take the Kotlin code and translate it directly into Java to allow supervisors to review your code in a more comfortable environment where they can understand what's going on a lot more clearly. Now, a crucial part of Kotlin is that it is extremely versatile. It can be used for back-end development, front-end web development, and primarily the way it's being used now is Android development and sometimes in iOS development as well. So let's take a look at some of the businesses that are already adopting Kotlin as their prime programming language. In May of 2017, Google named its preferred programming language for their App Store as Kotlin. Now, if we're looking at it today, 60 of the top 100 apps in the Google Play Store are written in Kotlin. That's a major. It's incredible that Google is adopting Kotlin as their primary programming language because it's such a large company, and they've actually also started writing a lot of their own applications and web apps and websites in Kotlin as well. Google Drive is actually ported completely to Kotlin, and they're actually working on transitioning to using Kotlin as the primary programming language at Google. Pinterest uses Kotlin for their front end development and for developing their mobile apps. That's a huge company, and another great, you know, another great point that Kotlin might be one of the next steps for a major popular programming language. And if we're looking at the back end side of it, the company Square, you guys have probably all seen it when you're trying to check out at some smaller store that Square adopted Kotlin for the development as their mobile apps as well as their server side programs because they have a massive consumer base, which includes a lot of extremely confidential data, credit card numbers and CCVs, and they use Kotlin's speed and security to make sure that their massive consumer base is able to be pleased by their platform. Let's yeah, well, that pretty much sums it up. I really do think Kotlin might be the future for Java. It really takes a lot of the things that Java does poorly and fixes it, as well as adds its own personal touch to it and adds that element of versatility where it can be where it can be compiled directly to JavaScript or to bytecode. Kotlin is an incredible programming language, and I think there's a very bright future to it. And I would totally recommend all of you giving it a look, taking a look at a couple YouTube videos and learning it a bit because it's really not difficult to learn it all. The syntax is not difficult. And the benefits for being able to put Kotlin on your resume are incredible because more and more businesses are adopting it as one of their major programming languages for their mobile apps specifically. And yeah, that pretty much sums it up. Here's a couple multiple choice questions. I don't know if I'm supposed to give you the answers here, but I'm going to go ahead and go for it. So, what programming language is Project Kotlin based on? We talked about it several times. Project Kotlin is based off of Java. If you thought it was based off of Prolog, you're going in the complete wrong direction there. How does Kotlin handle a null pointer? So in Java, it would throw a null pointer exception. However, as I pointed out in one of the earlier slides, when Kotlin is dealing with a null pointer, it will just completely refuse to compile. So the answer is D. It will not even compile if it detects that a null pointer exception will be thrown. So what company has adopted Kotlin as its primary language for app developers? It's certainly not the U.S. government because I don't think that they're developing apps right now. Apple is actually making some strides towards accepting Kotlin in the App Store, but as of now, Google, B. The answer would be B, Google. Google is an extreme fan of Kotlin. They think it is the future of Android development, and it's actually nested as part of their Android SDK that is available on Google's own website. So the final multiple choice question would be, how is Kotlin able to be used on any platform? Well, basically, because it is compiled directly to bytecode and run on a virtual machine, that allows it to be used on any platform that supports Java, which is pretty much every relevant platform, Windows, Mac OS, Linux, Solaris, any operating system that you will be working with will be able to run Kotlin code based off of the Java virtual machine. Um, Honestly, I'll be real with you. I might accept D as a second answer because it's incredible how amazing Kotlin is, and I really do think that it is the natural next step for Java. So yeah, thank you guys so much for listening to my presentation on Kotlin. Hope you enjoyed it. Everyone, good luck on finals, and enjoy the rest of your summers.